Nice. Love the energy. All right. With that, though, we're just going to quickly get you guys started. Let us know how you guys felt about how things went on Monday with a couple quick questions. Don't worry, these ones aren't 4 points. All right, let's take just a few more seconds to wrap up those answers on that first poll there. You guys are able to see the poll right now? I have no clue why, but my Zoom is kind of configured.
I'm also, just sharing the results right now. Are you able to see now, Richard? Or? I
am not. I am a little bit surprised about that, but that's okay. We'll keep rolling with it.
We do have 78% saying the bug buster exercises were great, so that's good.
That's awesome to hear. Thank you, guys. I love it. I'm glad to hear that you guys so far are enjoying the content. And we're going to have a lot of fun because variables is going to be the name of the game for today's session. It's going to be a lot of recapping stuff we already know, and it's going to be also introducing a couple new things on here to build on top. What's pretty darn essential to remember is that the way that our programming works is really that we keep on building on top of everything that we learned from the session before. So if you guys are getting stuck, if you guys have no clue what's going on, please speak up and ask, talk to your mentors or talk to me directly, and we can help you out on that. Because we are going to be building some really cool stuff, taking advantage of what we learned from last time. So let's go and get started. Just a reminder, we're recording everybody, but I'm going to get showing off something that I think a lot of you guys asked last time is how do you go and share your screen real quick? So let me just go and show you. I'm going to go and jump in. Let's go and I'm just going to create a brand new trinket just for today's purposes. And let's say I want to go and call this thing, I'm just going to call this session 2, how to share. I'm going to save that. And then after, I type in that regular stuff from last time, let me zoom in just to make it a little bit easier to read. From processing import star, and I'm just going to type in the bare minimum stuff here, def setup, open round bracket, close round bracket, colon, and I'll just type in size 500, 500. And then I'm going to press enter, and I'll press backspace to go line up just on the far left again, no spaces, def draw, open round bracket, close round bracket, colon, and then let's just go and say, what's some of the simplest things we can do? Let's just go and draw a rectangle here. That's going to be at, not with quotes, sorry. I'm just going to go 100, 200, 100, 100. And then finally, we get this run line here. So this is about the most simple program you can get started with. And we got that. Let's go and say, I want to go and share this and I want to show the world how I did that. After I press the save button to get that ready to go, I have this share button that's available for you. Those of you who aren't nearly zoomed in as me, it's going to be this button right here. You press share, you grab that link right there, and then you can just go and copy that. And then you go and shoot it off to the world, send it to whoever would want to go and see it. We have that submission link that was available, posted onto our Discord channel. And I believe our session number 2, you can find it in the slides themselves if you want to go and see that. Speaking of, how about I also just do you guys a favor? Those of you who want to follow along with me, I'll go and post our slides right into the chat so you guys can follow along as you please. But let's just keep going with that. So I want to just quickly recap a couple of things we saw written on our screen there. The from processing import star and the run lines, they are all things that you just can mostly ignore. They just simply exist there. But setup versus draw, these ones are going to be so common that I really want you guys to feel very comfortable with this. The setup area is code that runs just once and only once. And usually we don't put very much stuff inside there. We'll put the size function in there. And we can see that if you print stuff in there, it'll only just print it once. The draw function has this unique property where it runs over and over and over and over again. I'm taking an estimate of approximately 60 times per second. Do not quote me on that number. And it runs this code over and over. And one really particularly weird detail, and we'll come back to this later, is that the computer enters this draw function, it runs the code, and then it exits it, and then it'll re-enter, run the code, and it'll exit it over and over again. It's a little bit strange of a pattern to go and wrap your head around, but if you guys can keep that in mind, that's going to be useful for later. And that's really useful, especially when we have variables that are changing all the time. The particular ones that I want to go and demonstrate are mouse X and mouse Y. So we got our setup, we got our draw here. If, let me show you what happens if I do it wrong. If I set up my mouse X inside setup here, I can go and say print, hello, this is setup. And if I try printing mouse X, we can try running this code. So I'll go and stop that, run that. And hello, this is setup, and my mouse X is permanently locked to 0. It's never going to be changing. But if I take this down here, oops, let's go with print, draw is repeating, then when I print out the number mouse X, remember capitalized X, I stop that and run that again, you can see it's running over and over and over again, but it's automatically changing as we go. And if you guys remember, this is darn useful if we want to go and say, instead of putting the rectangle right at one fixed spot, we can go and make it follow our mouse by switching out the top left coordinates of our rectangle with the X coordinate. So how much is it to the right, and the Y coordinate, how much it is going to be downwards from the top there. Once we go and run that one more time, we can now see the rectangle following along the mouse. All right, quick ask for a recap here. Does anybody remember how I can go and remove this ugly trail that's following behind? How to make it not look like my computer is glitching out? Perfect. See, somebody's popping in the answer here. Thank you, thank you. So you're going to go and add the background function, and background basically just paints over the entire thing all over again. So you type in background, and let's go and say that today I want an orange color. So I'm going to go lots of red, so maximum red here. I'm going to go for green and blue. I think that's, if I'm remembering, we want a decently high amount of green for orange, and then we only want just a hint of blue. So paint background orange. Fingers crossed that I actually remember my color properly. There we go. Yeah, that's a good enough orange for me. I'm pretty happy about that. So we're going to go and just get these as our kind of our basics reminders for what we were doing last time. I'm going to take you guys to also see a reminder on what comments is. Comments are especially useful for just adding notes to your code that the computer straight up ignores. And I'm going to go and also highlight these two lines. So I'm just taking my cursor here, and I'm just going to highlight some lines with the shift. And I'm just going to press on my keyboard Control/, and it's automatically going to comment out those lines. So CTRL+/, on Mac, that's going to be Command+/ instead. And that's just a really cool way to go and quickly comment out code. And that way I don't have to go and delete it. But back to the main program. We're going to go and talk about variables instead. /. Excellent question. So that's Control plus this character. Thank you for that. Slash is very common in, very often you will see // what a comment looks like in different languages. Python uses the hash symbol. Different languages use a // as a common convention. That's why we use Control/ as the comment. That's just trivia for the side. You guys don't need to know that. Anyways, back to variables. I got a little distracted there. And I gave you guys a hint on what variables we can do with variables last time with the operators. We can go and actually like make variables very, very quickly. We can go and set the values of variables. So on this really quick example here, I have A is set to the value of 20. B is set to the value of 30. When I print out what is A plus B, that prints out 50. Hopefully no surprises there. When I print out A multiplied by B, that's going to print out 600. And then of course you could go and basically say, whenever you have a number, you could substitute it with a variable. So B is set to the value of, take a look, B, you just referenced, it says, okay, it's going to be 30. Subtract A, what's A? That's going to be 20, okay? So 30 subtract 20, that's going to be 10. 10 divided by 5, that's going to go and print us out 2. And what I want to go recap based on what we talked about last time is that variables are such an incredibly important concept. I gave you guys a taste of that last time with that last exercise where we had those snowmen and we wanted to figure out how to shift them over. One of the main benefits there is it makes it easier for us programmers to go and edit it on the fly there. And you saw that we only had to go and edit those 2 lines instead of making a billion edits all over the place. What's a really cool thing about variables is that you can also go and use them to go and edit things on the fly. The computer can edit it for you. You saw Mouse X was a fantastic example of that. All I had to do was wave my mouse around on the screen here, and it automatically changed the number. I didn't have to do anything. And the computer made it look like I was a genius. Yes, I'll pretend that I did all the magic here and not just computers. But anyway, variables, they're fantastic for things that are going to be changing all the time. And as a result, we want to keep track of these kind of numbers here. It's quite often to see variables used in literally any type of programming at all, but video games is one that's near and dear to my heart here. So let me go and take an example of a player's health. So I'm playing Zelda right now, and Zelda has a health point. He has a bunch of little Link has a bunch of little hearts on the screen. And every time he gets hurt, he loses some hearts. The variable to go and represent the health is a fantastic example of using variables right here, because it says that you have, I don't know, maybe 10 hearts or so, and ouch, you got hit. You lose 3 hearts here. Now your health is set to the value of 7. And I got some other examples on here as well. We have Mario who's walking around. Every time Mario jumps, you want to keep track of where Mario is, his position here. We got the score, we got enemies, etc. Does anybody else have an example of where a variable might be useful in a game? Okay, I'm liking it. Yeah, how many dots Pac-Man has eaten up so far, or how many cherries he has grabbed. Anybody else have an example? Well, maybe, for example, another one that you might see commonly if you're playing like something first-person shooter or Fortnite, something like that, like how many bullets you have inside your gun, or if you're talking about Mario again, what power-up has he just got? Does he have the mushroom? Does he have the fire flower, etc.? Anything that kind of represents the game itself, the information you can describe about the game really can be described using variables, and it's so incredibly powerful of a concept. And you can make some really fun things happen with this. Just a quick note on how we go and name our variables, because I tell you, oh my gosh, my #1 pet peeve is when people choose bad name for variables. So we'll just quickly go and show that variables, we typically talk about using lowercase names here. So if I want to talk about the x coordinate, yeah, x is an excellent name to go and talk about here. We would typically use lowercase x. So this is an example of good. And I'm going to go and list off an example of bad, which is technically possible, technically doable, but we typically avoid it unless if we have a good reason. Y variable is going to be like this. Don't use uppercase, just try to avoid them in general. Another good example is if you want to go and talk about some large variables strung together, or a large name strung together. So an example you might have saw me doing last time was talking about first name. You use the underscore to go and enter in the name here. And then we will go quotes, and then you can type anything in here. So I'm going to just use Richard. And yeah, feel free, I could choose capitalization, whatever I want. The bad side here is if I try last space name and is equal to Lee, and broken, can't use spaces in names or in variables. And those are basically just some of the good rules to follow. Finally, one final thing that personal pet peeve here is that when we choose names, we want to go and choose something that seems decently reasonable to keep track of. So date of birth. And then I can go and say, this is a good example of like Jan 1st, 2000. That's not my actual birthday. I'm just throwing in some dummy dates here. But I see sometimes people go and throw in some random things here. Like people just say A is equal to January 1st, 2000. can't read this. So the only one here that I really want to enforce is that the middle one is by far the worst because your code will completely break when you run this. The other two are fine. They're just simply not preferred. So good coding practices. If I can make you some good programmers out of you, I got to try. So on that note, let's go and just delete some of these blank variables. Yes, avoid uppercases in general for variables. There are some exceptions. When we're talking about processing, you'll find uppercases appear all over the place. That's something about processing, not really about Python style here. And another thing to pay attention to is that you might occasionally see in Python things that look like this: digits of pi, which is unchanging, 141592, etc. But you guys almost never need to worry about these things. So I'm not going to go bother talking about all these scenarios right now. So instead, I'm just going to stick with the basic scenarios. These are Python exclusive rules that I'm talking about. When you talk about different programming languages, they have their own different rules. These are called conventions. In other words, most of the times the computer really does not care. It'll run whatever code you give it, but out of personal preference, choose good variables and try to stick with convention. Your mentors will thank you when they're trying to read your code. Anywho, let's carry on. One other note here is that we are case sensitive. So if you do accidentally switch around a lowercase and an uppercase, you'll have a bad day. Don't do that. And try to stick away from names that are already reserved. So I know that don't name a variable print, for example. Don't name a variable import, etc. You're going to have a really confusing time when your program complains about something that seems absolutely nonsensical. Anyway, with that, I'm going to go and pop it to you guys to have a quick question. Let's go and take 1 minute to go and figure out, how do we use a combination of mouse X and those operators we just learned to control the size of the ball here? Notice mouse X is going to be pretty darn low. It's close to 0 when my mouse is on the left side. And mouse X is pretty darn big. It's, I don't know, maybe roughly 500 over here. How do you make the diameter of the ball match that? Let's open up that quick question. You guys got 1 minute. Alrighty then. Should be wrapping up pretty darn soon. And as usual, for some reason, my thing's broken, so I cannot see people's numbers.
Just 10 more seconds here, and then I will close.
For sure. I'll get you that slide link real quick. The two bottom questions on the poll are the same. That might be a little error on my side there. Should only be single questions at a time here. Darn it, I thought I fixed this last time. Turns out I have a couple more things I need to iron out.
Okay, we do have 56% on option number C.
Interesting, interesting. And if I'm able to actually, naturally I'm unable to go and actually see what those darn multiple choices are because something has been going a little bit weird, but that's okay. I got my own private side here that goes in and finds it. So we got 50% of you guys saying option number C. Congratulations to you guys there. That is the correct choice. For those of you who didn't get it, don't worry. We'll just quickly go and take a quick recap over what that is. And so we want to go and figure out how to go and make the mouse grow as we move on to the left and right. Oops, and I realized a little typo. We're supposed to use mouse X, mouse Y in the capitalized terms here, but we'll ignore that. You guys got the gist of it, which is to me a little bit more important. Let's go and talk about having our ellipse, and I'm just going to put in the right answer first, mouse X, mouse Y, and then we're going to say mouse X multiplied by 0.25, comma, and then mouse X again multiplied by 0.25. And let's just take a quick look at this. We will go and try to get that resolved in quick moments. I think that we should be able to go and help you out on that, Daniel. Make sure that you answer those quickly next time. They are called quick questions though. So just the one thing to note here is that the reason that this is the correct answer is that, yeah, we got the mouse that's moving to the left and right, and the circle, it's growing. And you might be wondering, well, okay, I chose answer D. How come I didn't get that right? The difference between answer C and answer D is that this mouse X is replaced with a mouse Y. And if you try running that and you take a look at your ellipse, well, you got something wonky going on. You got an oval, it's not a circle anymore. So little details really do matter. And that's what I think is going to be important to emphasize. Anyway, great job for those of you guys who did get that. We'll get you your points. And I want to go and jump into the next topic here. If you were paying attention to what I've been saying today, I've been pretty darn particular to say that this equal sign here, I don't say that X is equal to 100. I've been using the language X is set to 100. That's because this equal sign is really the assignment operator. Why programmers chose to do this, I don't know, but it is a very common convention to pay attention to this. And there actually is something called the equal operator. We learned that next week. But for now, focus on the fact that this is the assignment operator. It is not the equal sign. And this is the biggest differentiator from math versus programming. Variables are very mathy, but programming takes them to a completely different world when we say we set the value to be something here. We say that the left-hand side here, something on the left side of the equal sign, is set to the value of what's on the right-hand side here. So we say that your height is set to 170 centimeters. And so that says that you can specify how tall you are in your centimeters. And notice, if you try flipping this around, it makes no sense at all. 170 centimeters is set to the height. What? No, you can't do that. You cannot change a number to be set to something else. So you got to remember that your variable stays on the left side. It's set to the right side value. And the reason why this is so powerful compared to just using the grade or the old equal sign that you're used to, like in math class, is because now you can go and set it to a different value. The more simple example is down here. I'm going to show that one right now, in fact, and we're going to focus on that here. I'm going to go and use the setup section just because when I print it out, it doesn't spam all over the place. But this code does work just fine in the draw section as well. So I'm going to say height is set to the value of 170 centimeters. And then I want to go and say that my height is set to the value of, let's say next year you jump up by 2 centimeters. Height is set to the value of 172 centimeters. So let me go and print that out. Print year 1, your height is 170. Print height. Then print year 2, print height. And when you run this code, it goes and shows that the value is changed. On year 1, 170 centimeters. On year 2, 172 centimeters. We are using the exact same variable, but we're resetting the value every single time, which makes a lot of intuitive sense on when you just read it like this. If you tried approaching this with just pure math language, people who say 170 is equal to 172 is going to freak out and realize that this really is not having a good time. So no, it is not the equal sign here. It is setting. It is the assignment operator. And this enables us to go and do one very, very powerful trick with it. Because let me go and show you something. Maybe I want to say that I want the height to be set to last year plus 2 centimeters, right? So I'm going to go and say height is set to somehow do last year's height plus 2. What does that look like? What does this code look like here? Well, we have a rather nifty and simple way of doing this. What we type in here, let me go, would be height again plus 2. And if you, again, if this was regular math, you'd be freaking out right now. But in regular or just plain old Python, this is absolutely normal. You see this stuff all the time. What does this read? It says, in year number 2, my new height is set to the existing height I already am, plus 2 more. So this here reads, another simple way of doing this is just saying new height is set to last or to the old height plus 2. Also, I really am envious of anybody who can spring up 2 centimeters in a year. I'm no longer in high school, so I don't get those growth spurts anymore. I'm stuck at the height I am already. But anyway, this is a pretty crucial thing to keep track of, is that the new value is set to itself plus 2. And that's where you got to go and keep track of the new and the old. Toby, you beat me to the punch because I wanted to go and talk about that too. Because us programmers, the number one thing I've discovered about programmers is that they're absolutely lazy people. And programmers as lazy people want to type as little as possible. This pattern is so incredibly common where we say height is set to the old height plus 2 that we've actually gone and went and created a shorthand for it. So what I'm going to do, I'm going to take this line here. I'm just going to comment it out because this does the exact same thing. Height plus equals 2. This line here is the exact same thing as this line over here. Let me just go and clean up my comments here just so that you guys can read this a little bit easier. So this is exactly correct. Thank you, Toby, for pointing that out. That when you say height plus equals, that is really just typing out this link equals height plus all over again. And it's just a much faster way of typing it out for your convenience. Of course, naturally, that implies if there's a plus sign, can you use a minus sign? Yeah, absolutely. You could go height minus equals 10 if you got knocked over. I have no clue why you lose 10 centimeters overnight. That could kind of scare me. There's also some other weird variations that you can talk about as well. You guys don't need to know about these, but they're just kind of fun to know about. So you can say that your height multiplies by 1.01 or your height divide equals. So you take the height and divide it by 2. No, to be honest, you guys really don't need to worry about these situations. But I do tell you, when you start doing physics simulations and stuff like that, the multiply equal one is a really cool way of simulating friction, just as an example. But I digress. That's getting me totally off track. The one that you guys really should memorize is going to be this plus equals. If you're not comfortable with the plus equals sign here, yeah, go ahead and type out the long version here. That works absolutely fine. They are identical to one another. I'm going to be using a lot of this plus equals convention here, just because it's faster for me to type though. So feel free to type whichever one you please. Go back and stop me if you're saying, hey, I can't remember what this does. Richard, can you give me a refresher what plus equals does? But anyway, how are you guys feeling about that? Anybody feeling a little uncomfortable, need a refresher on how this works? Okay. Whoa, yes, there is technically a modulus equals operator too. That actually shows up occasionally. I've used it once or twice, but again, we won't need that one. But great question. Is everybody feeling good about this? Let me hear you in chat if you guys are feeling good about what we just talked about. All right. Okay, fantastic. X is equal to plus 2. I actually am not 100% certain what happens in that scenario because I don't often go and use. Python has a bunch of cool different features. I'm not quite certain what this one would do offhand. Height equals plus 2. Oops, plus 2. My best guess is that this would actually is height equals positive 2, which is the same thing as height equals 2. But Hamza, feel free to correct me in chat if I am wrong about that. I am going to carry on to the next topic though, or actually, rather than the next topic, I am going to just simply give you guys an exercise instead. I think this is an excellent chance for us to break out. Try exploring this for yourself. So here's the setup. I'm going to go and explain this really quickly. I got some code here. So I got def setup, size 500, x0, y 400. And we got some rectangles, one in the bottom left, one in the bottom right. And now if you notice this rectangle here, I did x plus equals 400 to draw that rectangle on the right side here. We're using the same x, but I'm using that plus equals operator to change its position. What I'd like you guys to do now, instead of just simply saying plus x plus equals 400, I'd like you guys to try messing around with that. X plus equals some other number. I don't know, maybe 100, maybe 5,000, I don't know, something like that, so that you can go and get this cascading pattern. You're going to also need to go and change the y value. You're going to need to say y plus equals, or maybe y minus equals something, to get this little diagonal pattern here. Let's go and take 8 minutes, try out this exercise here, and see if we can figure this one out. This is not the big bulky one, and I know that we have another exercise coming up that I want to give you guys more time to work on. All right, then. Okay, welcome back. Let's get this recording back on the roll here. Welcome back, guys. Hopefully you guys were able to get some progress on this exercise. I know this one was a little bit rushed as well, but not to worry. This exercise here was mostly a primer for one of the upcoming exercises, and that's the one I wanted to give you guys a lot more time and attention to get done. So let me see. I'm going to just go and quickly show off how we go and get this part done here. So I'm just going to go and get rid of some of this code here, and I'm going to get put right here inside our draw section. Yeah, that's absolutely fine, Daniel. Don't sweat it. These exercises here, as long as you can figure out that if you want to have like an x set to be at 0 and a y is set to 400, and if we want to draw a rectangle at x comma y comma 100, 100, we can draw our first rectangle right there in the bottom. And I'm going to stick with that orange color, even though we're supposed to be using that bluish color. And when I say, if I want to go and update that to draw the next coordinate over, I go x plus equals 100. And then I'm going to also draw my rectangle, x comma y, 100, 100. When I do that, that draws the next rectangle over adjacent to it. And if I want to go and bump it upwards, that means I want to subtract off of my y dimension. Remember, down means positive. So I'm going to go y minus equals 100. And we can go and do that. And we can get our next rectangle. And honestly, at this point, I actually was expecting you guys just to do this. Take this link and literally just copy paste a few times. And that's it. This exercise here was just to go and get you guys, your brains warmed up on using these numbers. Let's jump into a little bit more of an advanced topic here. And this is one that I've seen historically with previous students. They struggle a lot to understand. Sure, you know what? How about I go and share that real quick, just so that you guys can go and see this. So session 2, exercise 1 solution. And then we'll go and save that, share that, copy that link here. I'm going to pop that right into there and just out of convenience, S2 exercise 1 solution. And drop it straight onto our Discord as well, so you guys can find out later. But what I wanted to go and show you is a topic that lots of people have been struggling with in the past. So pretty please, if you get lost at any point here, feel free to interrupt me and ask questions. I pointed out one rather strange detail earlier at the setup and the draw function. The setup, it runs just once, it's fine. With the draw function, our computer enters and exits it over and over again. It enters draw, runs the code, and exits it, enters, run, exit. And it's going to be a detail we want to pay attention to. And I'm going to tell you why. Because we got this thing called scope that exists inside our variables. And scope is an excellent thing if you're a senior programmer and you know what you're doing. But for junior programmers, it's a topic that people tend to struggle with a lot. It basically says that variables only exist as long as that function block exists. So let me just go and scrap a lot of this code here just so that we have something nice and simple to talk about. So I'm going to go and hump it down to its bare minimum. And I'll just keep that size line there because it's pretty darn handy. Basically, the issue that we're going to be facing here is that we have a limited scope on our variable. And I'm going to go and just show a code example, show you what's broken about this, and then we'll go and I'll jump back into the slides where I originally was. So if I have a variable, let's just go and say x is set to the value of 100 right here. If I go to my draw function and I go and print x, you'd be like, okay, well, that's nothing too crazy. But when I try running this code, there's a big red angry error that shows up at the bottom of my screen here. Name error, name x is not defined on line 9. And you might be looking, you're like, yeah, there's an x right here. X is defined on line 6. X is set to 100. But because of this concept called scope, it gets a little bit more tricky than that. The computer's technically right, and here's why. Because, let me just, make it a little bit easier to read. When we have this setup section here, we create this x variable. And when the computer's finished on this, it's going to say x, all right, I'm done with you, bye-bye, throws it away forever, and you can never find it again. When you enter this draw section here, it enters and it says, where's that x? Well, I don't see any x, what's going on? And your computer freaks out. I can't print something that does not exist. And so that's where this whole concept of scope kind of comes into play. For those of you who might be looking a little bit confused right now, let me go and try that out with an analogy, go and explain this. Scope is kind of similar to talking about laws for my analogy. And I want to go and talk about two different laws. Here in Alberta, or Canada in general, we can go and say that the legal drinking age, if you are 18 or older, you're allowed to drink. That's the law of Canada, Canada's law. You can see I'm holding a little yellow ball in my hand here. In the United States, they also have a law, and they say you must be 21 years old to drink. If you notice, those two laws are directly different than one another. They're not the exact same thing. Heck, if you're inside Canada, the Canadian law does not care about the American law. The American law, likewise, does not care about Canadian law. So if you're 19 years old and you're in the United States, if you're in Washington and you're trying to crack open a beer and you say, well, it's allowed in Canada, too bad, so sad. You're not in Canada. You're in the United States right now. You're not allowed to go and drink. So naturally, that's a good way to go and keep things nice and separated here. But there might be some times where it's awfully handy to go and talk about a universal law that applies here. So one universal law that I believe that I hope all of you guys are following is that there should be no slaves. Nobody should ever be a slave at all. And that's kind of enforced by the United Nations, and this is applied globally, which coincidentally, we stole this word global in our programming world here. So when I'm inside Canada, I can go and refer to the global laws, the United Nations laws, and I can say there's no slaves. If I'm in the United States, I can also say, look at the global laws. There are no slaves allowed. It doesn't matter if it's written in Canada. It doesn't matter if it's written in USA. It is globally defined to say that there are no slaves. And this base analogy here, I'm talking about variables. So when I'm talking about these laws, each law represents a variable. So when I was talking about the variable X, that's kind of like the law that belonged inside Canada. And when I was talking about that inside setup here, it belongs in Canada. When you exit Canada, it's gone. And now when you enter the United States and you talk about your variable, or sorry, draw, not the United States, go with my analogy here, you can go and say that, yeah, okay, maybe we have X is set to 200. And sure, now we have X and that works, that's fine. But here's one really weird quirk about programming, specifically this processing stuff here. And this goes back to what I was talking about earlier. Every time the draw function runs, the computer enters and exits. And what happens when we do this, with this weird entering and exit nature here, we enter draw, and the first time around it says, okay, I'd like to go and create a new variable, and I will call this thing X, and I'll give it the value of 200. I'm going to print it out. When I'm done with printing it, what am I going to do with it? I'm going to exit. How does it do that? The computer throws it away. And then it goes and re-enters and says, okay, I'm going to create it all over again, create a 200, and then I'm going to print it, and then I'm going to throw it away. And then on the third time, you go and enter, you go create the 200, and then you go and throw it away. I know it does sound rather redundant, but this is a good way of how the computer works if you can learn all the other extremely complicated details that wrap around it. But don't worry, those are university classes later. I'm not here to teach you those today. So you might be wondering, okay, is there a way I can go and hang on to this link permanently so I don't have to throw it away every single time? Because one thing I would like to do, for example, is I would love to do x plus equals, let's just say 1 here. I would love to say x, set it to 200, change it to be 201, prints out that 201, and then bring it back. What I would like to do is then talk about it being 202, because I do run this line again. And then I'd like it to be 203. I'd like it to be 204. I want it to keep on growing every single time. But right now, that's not possible. Here is how we're going to go and change this up to make it possible. I'm going to delete this line just to remove some confusion. And I'm going to go and say, let's make one of those United Nations level laws. Let's go and make it global. So I'm going to exit the setup section. I'm going to go to the very top, just underneath the from processing section here. And I'm going to say X is set to the value of 200 all the way up here. And now down here, I'd like to say, I don't want to use this X that belongs inside just draw, or I don't want to follow just the American law. I want to go and follow the global nations law, or basically I want to go and follow the global variables. So I'm going to say global X. This line right here says, please use the global variable named X. And now when we do that, we actually have a way to go and access it. We enter draw, and this first line that says global X says, please use the existing global law X, which is currently set to 200. Change it to be equal to 201, and then print it out. And then change it to be equal to 202, and then print it out. Every single time we exit here, we re-enter. We're going to grab the existing one, change the existing one, and then when we exit here, we do not throw it away anymore because it's stored globally. It's going to hang around forever. And when we run this code here, I got some variables. Oh, wow, that's going really fast, but it's going up and up and up over time. What I'm going to do now is show you something pretty darn awesome that we can do this. Rather than just printing, I tell you, computer printing, that's so old school. I'm going to go and show you what happens if you instead use that for drawing purposes. Let's go and set a rectangle with that. I'm going to go and create a rectangle, and I'm going to set it to the X coordinate right here. And then I'm going to go and set the Y coordinate. I don't know, maybe 100 is going to work. And then I'm just going to make this thing a little bit smaller. And then watch the screen here. You got a rectangle that sweeps across the screen. If we go and add in that background command too, I'm going to go and say background is going to be pure white, or not white, let's choose black. Pure black, 000 is a good color for that. We can go and get a rectangle that moves. And in my opinion, this is kind of one of those really cool discoveries that I had when I was first learning how to go program, because this is how you make animations. This is how you make something awesome show up on your screen. I'm going to take this 200. Let me just tweak it to 100 just so it stays on my screen a little bit longer. And what I want to go and illustrate here is that just with a couple lines of code, you can go and make your own animation. Now, previously we had a player that you can like interact with your mouse and you can create a video game on that. But now we can talk about like making an enemy walk back and forth. You can talk about a bullet flying across the screen. You can talk about a spaceship trying to go and navigate around asteroids that are raining down on you. There's actually so much potential around this area here. And that's why I'm personally so excited about the fact that we can go and make some animations by using this global variable. And I want to go and show you guys, I'm just going to walk through the code here, that exact same thing on the slides here. This is where it's broken. And this is where we create that global variable. And we can go say global X, and we can go and modify it there. And this is how we basically go. X is in set to 10 here. We global X to access it. And then we can go and use that over and over again. And I'm going to go and, oops, before I show you that quick question, I'm going to just quickly ask, how are you guys feeling about this? Are you guys feeling like, yeah, that totally makes sense? Or are you feeling like, I kind of need a second explanation. I need somebody to show me how that works. How are you guys feeling? To slow it down, it would be just x plus equals 0.5. Toby, I think you're on the money there. You can change x plus equals to be a different number. Daniel, don't you sweat about it. One simple thing you can do is just simply copy down the code you see on this screen here, and then I can go and you can go and kind of stare at the pieces over and over again to kind of figure out. One cool trick that you can do just for learning purposes is just take a piece of code here, try deleting a line, run the code again, see what happens. 9 times out of 10, it'll break, of course. But if you can figure out why it's breaking, it is a huge insight. And Toby has a great idea. Yeah, change this out. X plus equals, or X equals X plus 1. What happens if that's 2? What happens if that's 10? Try changing those numbers out. What happens if you say X is set to 10 up here? What if you change that out? Albert has a question. Was the reason the streak appeared to be black because the border of the square was black? Yes, that is because I chose the background to be black on there. Or sorry, not background, the stroke to be black on there. So if I go and change this background to be red, we have a really bright red here, and I'm going to say X plus equals 2. You could see, oops, sorry, I need to get rid of this background here. So comment that line out. And yeah, you can go and see there's a streak here. And if it's set to 5, it becomes more and more obvious that it's just simply the stroke pattern behind there. Yeah, if you're feeling lost about this, do not sweat. We do have a bunch of exercises built up so that you guys can go and work around this. But I'm going to go and quiz you guys now and check out how well you understand. Because let's just go and say I'm a junior programmer. I have no clue what I'm doing. And I decided just trying to follow along and write some code here. Can we change the color of the border of the square? Yes, you can. I'll show you that after this quick question here. I got a quick question. I want you to go and try reading the code. Somebody was just trying to follow along and try to get a circle moving across the screen, and they wrote this code. Is it working? Is it not? I'll give you guys a minute to go and try to figure out.
Okay, we'll just do 5 more seconds. All right, I'm just going to end the poll right now.
All right, and how did our students do?
And we're getting 60% that have selected the correct answer, which is option number 4.
Excellent job, guys. Great job. So no, the variable X will be redeclared, reset every single time this draw happens, and the circle does not move. Let's just quickly show what happens if you screwed this up and did it wrong. What would it look like? So I'm going to take this line, X is set to 100. I'm going to get rid of that here. And I'm going to just say X is set to 100 right here. And then I tried going and drawing this. This is almost identical, so you guys will forgive me. Basically, you can see that it's set to 100, and it's changed to 105, and then you draw that rectangle. And so that's drawing the rectangle at 105, draws at 105. And then you go and exit here, and that means take that 105, throw it away, bye-bye. And you try again. You set X is going to be, create a brand new variable called X, set it to 100, change it to 105, draws it at 105. And this is going to be stuck here over and over and over again because of the fact that we keep on resetting its value. So remember, if you want to make it work, you got to use this global keyword here. You get rid of that line right there. Just get rid of that distraction. You put it up here instead. X is set to 100. And that's how you can go and get yourself an animation running. Okay, I would promise you guys will get some time to work on this, but I'm just going to quickly talk about some other things. I saw somebody asking a question like, whoa, what happens if we change the speed here? And I want to go and experiment with this. Don't worry, this is mostly along the realm of kind of bonus material stuff here, but I do want to emphasize, wherever you see a number, you can replace that with a variable instead. So basically, let's go and talk about, back over here. We got X is set to 100. I'm going to dial it backwards just to X is set to 10. And if you guys run that again, that just simply starts further to the left. And I'm going to keep all this global stuff here. Let's turn on the background. So if I run that big red background, and somebody asked me about how to set the stroke style here. Excellent question. I showed you guys how to set the fill. This is how to go and change the color of it. And I'm going to set this link to be blue. Let's go and set the stroke to be, you know what? I think that it's stroke of green or light green. these might be some horrendous colors, but it should get the point across. Set the border to be green. And so, Sihan, I think that is how to answer your question on how do you set the stroke here. If I remember correctly, I can't remember exactly. If you set the stroke width with a capital W, oops, nope, that's not it. I don't remember how to do that, so I'm going to show you that later. Stroke width is not important. We'll never ask you guys questions focusing purely on the stroke here, so don't worry about that. But what is a little bit more important to talk about, we have this x plus equals 5. I could change that out to be x plus equals 1, and that kind of crawls across the screen kind of nice and slow. If I set it to x plus equals 10, instead, it blasts across the screen like a bullet. I can set it to 100 and it'll be gone before you even blink. But I can go and basically say x is plus equals. I can set it to a speed variable. I'm going to go create a global variable called speed. Speed is equal to, let's say, 2. Just for a case of my example here, I'm going to say global x, and I'm going to say also global speed. So that's going to be global x, comma, speed. That's how I access it there. And so instead of saying x plus equals 1, 5, 10, whatever, I can say x plus equals speed. And now it says x plus equals 2. And that's a pretty darn cool and simple way of getting it to march across the screen here. I set this to 100. You can go and control the position that it starts at. And if I change this variable here, you can go and change the speed it works at. You got 5, you got 3 to slow it and get a little bit slower. You got 1 to slow it down a lot. And I'll even give you guys a spoiler. If you set it to -1, some other cool effects happen. Actually, never mind. I'm not going to spoil that. I'm going to leave you guys to discover what that does. But let me go and show you as well just some other cool things that we can go and do with this here. So what happens if I set the speed to 0? If I set the speed to 0, I'm saying x plus equals 0. X is set to the value of the old x plus 0, basically doing nothing. But I can do some really cool shenanigans here on the line before. And this is just totally bonus material, so do not freak out if you don't understand this. I'm going to say speed is set, or is going to be set to the value of itself plus equals 1. So the speed is going to be growing. So we're going to have speed of 0, set it to grow there. We're going to have speed is set to 1, speed set to 2, speed set to 3, speed is set to 4, and the x here is going to keep on growing with that. And what you have as a result is zoom. You guys didn't notice that. I'll play it again just so you can see. Starts slow and boom, it races off really quickly here. You have a really cool way how to get acceleration off there. And I can tell that some of you guys can figure out a really creative way how to go and transform this into gravity instead of x coordinate. You just flip this on its head, turn it into its y coordinates. And for those of you who have taken physics 20, all those crazy kinematic equations to go and describe a huge parabola and this crazy arc, I could do that with just a plus equals operator. And in my opinion, that's so cool that you can get such an advanced topic in such a simple amount of code and with no needing to understand a quadratic formula at all. So that was me just being a little bit excited about that here. But yeah, here we go, just for completion. What does that code look like? Anyway, I'm going to go and give you guys this exercise here. And this is the one where we go and work on this plus equals concept. I'm going to give you guys 10 minutes here to go and get the ball moving diagonally downwards. I want you guys to focus on getting some other more basic parts done instead. So if you guys really have been struggling to follow along, focus on step 1, just making it move to the right side. And then step 2, make it move downwards. You can combine those together, that would be diagonal. Finally, if you're feeling up to the challenge, this is a bonus. Figure out how to get that color to fade from a red to a blue. Let's take 10 minutes to try that out. Okay, welcome back, guys. Welcome back. So, how are you guys doing with that exercise there? Let's see a show of hands, or type in chat, sorry. Let's see you guys in chat here. If you guys were able to get your ball to be able to move at all, any direction is fine with me. Okay, good. We got some people who got some movement on the screen. Yep, that's awesome. Anybody else manage to get movement on the screen? Excellent. That is fantastic stuff. I'm seeing lots of people saying yes here. That is great. Sounding good, sounding good. Fantastic work, guys. And the secret to getting this entire exercise done, let's see how quickly I can program this on the fly. I probably should go and make a new trinket for this, shouldn't I? And so I'm just going to go and create myself a new trinket. It does, and I'm going to go and borrow this code because that's rather convenient here. And except for I don't want that crazy background. It's way too harsh on my eyes. So basically what we can do here, I'm just going to get rid of speed and I'm going to instead replace it with the letter Y. And you guys I don't want to spend too much time talking about a solution here because you guys mostly got a chance to work with this with your mentors already. Basically, the way that we do this is we're going to go and set fill to be something, I don't know, let's go and set it to black. So 0, 0, 0. Or I can just do this shorthand here, set it to grayscale black. That's what happens if you choose just a single number instead of 3 numbers. It just simply does all 3 numbers at the same time here. And then we're going to draw our ellipse at x, comma, y, comma, and then we're going to set this, I don't know, maybe make it 50 by 50. And if you run that, still stuck in the corner, doesn't do anything yet. So let's go and have some fun with this thing by saying x plus equals, let's go 2. And then you can also just go y plus equals 2. And then when you run that, it starts marching down across the screen here. For those of you who wanted to figure out how to do the multiple colors rather than just simply doing this, let's go and add in some other values. We got r is equal to, if I remember correctly, we want to make it all red first, and then we want to make it green is we can safely ignore, so we won't use that. And then we're going to have some blue here that starts at 0. And that's possibly the most tricky part here, RGB, or red, green, blue. And we'll set our fill here to be red, green, and blue. And we're going to go and say R minus equals to G, or I'll just use minus equal 1. G, we can completely ignore because it's not relevant here. And we'll say blue plus equals 1. And then that is how you can go and get that beautiful gradient across the screen as well. Let's go and save this section 2, exercise 2, solution. And I'll go and pop this onto our Discord here so that you guys can go and see this as well. Okay. Any questions about that? All right, then. We only got one basic topic left. And these are honestly just mostly for fun here, and it just makes your diagrams look a little bit more cool. So do not worry too much about these. So basically, I wanted to go and show you guys how do you go and get some more things on your screen. First things first, I'm going to show you guys how you can go and get some text on there and how you can go and draw a line on your screen as well. So I'm going to go and try setting up. I realize that editing an existing trinket has some bad ramifications. I really should be using brand new trinkets whenever I need to. So let's just get rid of these other ones here. And then I'm going to go and create myself a brand new trinket. And the first thing I'm going to do is I'm just going to go and draw some text on my screen. From processing, import star def setup, and we'll just use our regular size 500 pixels by 500 pixels, def draw, colon. And then what I'm going to do with my draw, I'm going to show you, I can use the text command and I can go and say hello. And I can go and set it maybe at the X coordinate of 100 and the Y coordinate 200. And I can go and run that thing there. And there it goes. And ooh, that is not very easy to read. In my opinion, that's a little bit too small for my comfort. What we can do with that, go to the line before, and we can go and instead set the text size. And let's bump that up. Let's try 30 and see how that looks. And there it goes. It blows it up to be a much nicer one there. You guys can mess around with the text align as well. Albeit, truth be told, I would kind of tell you guys to ignore this left baseline thing. If you guys want to have it right aligned though, you can go text align right. Yes, all capitalized letters here. Here's an example, all capitalized. And then you just stick with this baseline. I don't think that you guys need to actually memorize what any of those do. And in my opinion, it's not a very useful one. So I'm just going to go and ignore that. But you guys have that available on the slides. There's left, there's right, and there's center as you guys need. how about we go and talk about drawing a line? So we can go line, and basically we're going to specify that x1, x2, or x1, y1, that's the starting position, and we'll go to x2, y2 as the ending position. So let's just go 100, 200, that's the starting position, 100 across, 200 down, so that's just starting at the hello, and then it'll go 300 across, 400 down, 300 across, 400 down, and that's where it's going to start and stop. We'll paint ourselves a nice little line right there, black line. Let's see if I remember this correctly. If not, this is going to be a little embarrassing for me. I can change the stroke out. Let's go and see. Let's go and make this thing a, what's a new color combination I have not done yet? Green plus blue. What does that equal? Kind of that aquamarine kind of color here. Ooh, there it is. It's kind of hard sliver to see. And I saw somebody ask me this question earlier, and I screwed up last time, but I finally remembered. You can use the stroke weight to go and say how thick your line is going to be. So let's go and say the stroke weight is going to be 5 and capital W on that. And with that, you can get a thick line. And that's still super hard to read. So I'm just going to go and bump down these values here. Instead of 255, 255, I'm just going to use 150 to make it slightly darker and a little bit more visible. And there you go. You guys got some extra features here you can play around with. I'm not going to spend too much more time on that, but you guys can go and learn a lot more about these on your own as well. There is an excellent spot here, Python mode for processing. Here we go. I'll drop this straight into chat here, where if you guys take a look at the reference, you can find all the different settings that processing lets you do. So there's a triangle function inside of here. You can go and set some other details. I don't want to rely on this too heavily because I noticed that unfortunately it's not perfectly updated. For example, circle is unavailable, or else I'd be using circle instead of ellipse all the time. So just take that with a grain of salt. But it is fun to know that these things exist. And it's pretty cool to say that you can combine these things too. So this particular slide just showing off some examples, basically showing off about what you can do if you're having fun with it. So if I say font size, and I set that value to be 20, instead of saying my text size is going to be one single solid number here, we can say global font size. And I can just simply go and put that into here. And of course, when you run that, it just simply changes the size. But you guys probably know where I'm going with this. I'm going to go font size plus equals 1. And then we can have this thing blowing up as big as we want. Naturally, of course, I should have added a background command to go and stop that. And there it goes. And then you can get yourself to say hello to go and tell the world about how cool your program is. With that, fading colors, I've actually already talked about. I'm going to skip that because I want to give you guys some time for exercises. And speaking of exercises here, if you guys are in Bugbuster, which I believe a grand majority of you guys are, make sure you just simply submit it to this link here. We've got those links up and running now, and we'll share those again on Discord. And basically, we will be asking for these submissions by next week. So here we go. Here's a couple of exercises I want you guys to go and work on. This time round, if you guys want to get these done, figure out how to get these built for 1 week from now, and we'll give you 50 points for each one you do. Let's get rocking with that. Let's go and get open here, and I'll meet you back here at 7:30. Hey, welcome back. We're on the tail end of our meeting time here, so I'm not going to take very long. But that's about it for session number 2. We're done the content. On Monday, the session 1 material is due. You guys have to get that submitted and everything. On Thursday, session number 2 stuff will be done as well, or you guys will get that done. And I'll see you guys here again for session number 3 starting Monday. But before I do that, I do want to go and quickly show you guys over here on our Schulich Ignite Discord, and ignore the fact that you can see a lot of the secret stuff. But if you guys have not joined our Schulich Ignite Discord, this is a spot where you can go and chat with your mentors, say hi, and go and talk to them outside of hours. You can also ask me questions outside of hours as well. This is your easiest way to go and reach us. And this is a 7-day link here, which will surely expire, but I'm going to ignore that. What I want to go and show you guys as well, really quickly, is that there's a lot of people who've already figured it out. Thank you guys. But for those of you who have not yet, you guys can go and jump in and talk with your mentor in a private channel dedicated for you. So that'd be squad, sets, summer 22 dash, and then your group number in here. So the group numbers I have listed inside the announcement channel. So for example, Redspreet's group, I know offhand is going to be number 1, and then Ryan's group is going to be in number 7. If you don't remember which group you are in, you can just go check out the announcement channel right here, find your mentor and type that in. This gives you private access that only you and your group can chat with. And I think that's pretty darn awesome. Let's wrap up right here. Anybody have any closing questions before I let you guys go? All right. You can find your group by checking out the announcement channel. Okay, so right here, the hashtag announcement channels, it has listed all the different mentors here. You can go and find your group number. Then you can go and type in your command to go and jump in. And I see people are already doing it right now. Fantastic. If you guys got any other questions, feel free to stay around for like 1 or 2 more minutes. But other than that, students, you feel free to take off, and mentors, I'll chat with you afterwards. All right, bye guys.